Good morning, students. In previous classes, we discussed two-phase locking protocol. In two-phase locking protocol, there are two phases. One is growing phase where all the locks are issued, and shrinking phase where all the locks are closed, that is unlock issued. Now today we discuss non-two-phase locking protocol. In non-two-phase locking protocol, we there are two different methods. One is graph based protocol or tree based protocol, another is timestamp based protocol. To develop this two-phase lock non-two-phase locking protocol, we must have additional information, and that information is that how each transaction will access the database. We must know this prior. Now, graph based or tree based protocol. Now, for graph based protocol, it some requires some power and knowledge, and the first knowledge is the order in which the database items will be accessed. In graph or tree protocol, where the data items are arranged in a tree. In this protocol, the nodes of the tree represents that item to be accessed, and x comma y is an arc of the tree where x is called the parent node of y, and the transaction access the subtrees. An entity can be accessed after all its ancestors in the subtree have been accessed. Now, there are some specific rules, that is basically four rules to develop the tree based protocol or graph based protocol. The first rule: no data item can be accessed unless the transaction locks it. That is exclusive lock. That means only the data item can be accessed after it will issue the lock, exclusive lock on that item. Second rule: a data item X can be locked by a transaction T only if currently holds the lock on the parent of X, unless X is the root of the subtree accessed by T. That means we can only give a lock to a specific data item X if its parent is already locked. Otherwise, we can't lock. Third rule: a transaction T after unlocking a data item cannot subsequently relock it. That means if a transaction T1 unlock a specific data item, suppose A, it cannot be locked again. But after unlock or without unlock of a data item A by T1, other transaction T2 or T3 can be locked that item. And the fourth rule: transaction can unlock data items anytime. That means at any point of time transaction can unlock. That doesn't mean that the parent nodes or the child nodes is locked or non-locked. Okay. Now here we consider a tree where A0, A1, A2, A3, A4, A5, A6, A7, A8, A9 and A10. These 10 data items are locked, and we design a tree, rooted tree. Now we check for these three transactions T1, T2 and T3 whether these three transactions satisfy this tree or not. At first we check the transaction T1. Now for T1, lock A0. Here in this transaction I consider all the simply the lock and unlock condition, unlock statements. Other statements are there, the read write operation, okay, but only we here we consider the lock and unlock statement. Now T1 lock the item A0, it will be starting, so it may be locked, no problem. Now T1 then locked the item A1. Since A0 is the parent of A1 is already locked, so we can lock the item A1. Now for lock A4, we can lock this item for T1 since the parents of A4, that is A1, is already locked. So that means suppose A0 locked, A1 locked, A4 locked for T1. Now unlock A1. So unlock A1. We can't lock A1 again in T1. That is the rules. Now lock A9. We can lock A9 because the parents of the lock A9, A4 is already locked. So we can lock A9 for T1. Then unlocked A4, no problem. Unlock A9, no problem. Okay. Then lock A2. We can lock A2 since already locked A0 is there, the parents of A2. So we can lock A2. Lock A5. We can also lock A5 as the parents of A5, A2 is already locked. So we can lock A5. Now we unlock A2, unlock A5, unlock A0. So T1 satisfy this tree. Now we check for the T2. Here again we lock A1. So we consider this A1. Okay. Since it is the first, so we consider this lock. Then A4. A1 is the parent of A4, so we can lock also A4. Then lock A10. Here A10 is the child of A4, so we can lock this thing. Then unlock A4. So unlock A4, no problem. Lock A3. We can lock A3 because the parents of A3, that will be A1, is already locked, so no problem. Then lock A7. So lock A7 since A3 is already locked, so lock A7 is possible. Then unlock A1, no problem. Unlock A10, no problem. Unlock A3, no problem. And unlock A7, no problem. So T2 is also satisfied this tree. Now we check for T3. So T3 lock A3. So we consider this will be as a lock. Okay. This is the first transaction, so no problem. Now second transaction, lock A7. We can lock A7 since A3 the parent is locked, so that will be the locked, no problem. Lock A8 since A3 the parent of A8 is also locked, so that will be no problem, we can lock. Then unlock A3, no problem. Unlock A7, no problem. Unlock A8, no problem. That means T1, T2, T3 are satisfy this tree-based protocol. Now we check whether this will be serializable or not. Now check for T1 A0 A1, there is no any A0 A1 in T2. Now A1 is there, so there will be a arc from T1 to T2 by A1. Again lock A4, so T1 to T2 and arc by A4. And A2 A5, there is no any A2 A5 in T2 or T3, so there will be no any arc. Now from T3, A3 and A7, A3 and A7, here also A3 and A7, so there will be an arc from T3, A3 and A7. So the precedence graph will be there, and there will be no any transaction from T3 to T1. So from T1 A1 A4 to T2 and T3 A3 A7 to T2. So this is not a cyclic in the precedence graph. We say that will be the serializable, and the serializable schedule will be either T1 T3 T2 or T3 T1 T2. And whatever the problem arise in the two-phase locking protocol, that is the deadlock, here we overcome this deadlock, because in tree-based non-two-phase locking protocol, in tree-based or graph-based protocol, we parallel know the order of the sequence, so there will be no any deadlock. Now what are the advantages of tree-based protocol? In case of tree-based protocol, unlocking may occur earlier. That is, in two-phase locking protocol, in the first phase, that is the growing phase, we declare all the locks. That means whenever an item is unlocked, another transaction cannot be uh, consider that item. So the waiting will be there and concurrency will be less. But in this protocol, we can't give the unlocking in any place, so the waiting time will be less and the increase the concurrency. And because we know the previous order of the transaction previously, so there is no any deadlock and no need to roll back. Now what are the disadvantage of T-based protocol? That is, at first we know the parallel knowledge of the data access, how the data will be accessed by the transaction, and second is unnecessary locks. Unnecessary locks means in here that is the first transaction T1, the lock A1 is not required for our accessing, but we want to access the item A9, we must lock the item A1 first. So that unnecessary lock is there, and that will be a problem. So this is the non-two-phase locking protocol, the first kind of non-two-phase locking protocol, that will be the graph-based protocol. Here again I just repeat the graph-based locking protocol. In graph-based locking protocol that we want to develop, we must know the order of the database item will be accessed. Second, we design a tree where all the nodes are the data items and all the arc x comma y, where x is the parent of y. And to design the tree-based protocol, we have some follow the rules. The first rule is no data item can be accessed unless the transaction locks it. That means when we start it to access a data item, we must lock that data item. and for initially the data item we can lock any data item. Second, a data item X can be locked by a transaction T only if its parent's node is already locked, unless the X is the root. That means initially we can lock any data item, but next whenever we try to lock any data item, that will be the child of the locked data item. Third point, a transaction T after unlocking a data item cannot subsequently relock it. That means suppose T1 at first lock the data item X, then sometimes after it unlock the data item X, then T1 cannot be locked again X, but another transaction T2 or T3 may be locked the data item X. And the fourth rule, that anytime transaction can unlock a data item, that there will be no specific boundation that after all the locks are complete then we can unlock. In the two-phase locking protocol there is no any such kind of boundation, we can unlock the data item anywhere. Now we design a tree like this, and here is some specific transaction T1, T2, T3, and we just write the lock and unlock comments only, and other comments, that is read write operation, will be there. No need to write these things because we just consider the lock and unlock statement for this tree based protocol. Now we check whether T1 satisfies this tree based protocol or not. So in T1 at first lock A0. So we consider that A0 will be locked. Then lock A1. Since the parent of A1, that is A0, is already locked, we can lock A1. Lock A4. The parent of A4, that is A1, is already locked, so we can lock A4 also. Then unlock A1, no problem. Then lock A9. The parent of A9, that is A4, is already locked, so no problem, we can lock A9. Then unlock A9, no problem. Lock A2, sorry, unlock A4, that will be also no problem. Lock A2. Since the parents of A2 is A0 is already locked, so we can lock A2, as well as lock A5, as the parents of lock A5, that is A2, is locked, so we can lock A5 also. Then unlock A5, A2, A0. That means in this case we want to lock the item A9 and A5. For locking this item A9 and A5, we lock A4, A1, A0, A2. These extra locks are unnecessary. But in this transaction T1, that satisfied this tree. Now for T2, lock A1. So initially we start with the lock A1, no problem. A4, lock A4. Since A4 is the child of A1, so we can lock. Then lock A10. Since A10 is the child of A4, so we can unlock A4, no problem. Lock A3. We can lock A3 because the parents of A3 will be A1, that will be is already locked by T2, so we can lock A7. Since A7 is the child of A3, which is already locked, so we can lock A7 also. Then unlock A1, A10, A3, A7. So that will be satisfy also, the T2 satisfy the also this tree. Similarly T3 satisfies the tree also. And here we draw the precedence graph for this transaction T1, T2, T3. and we see that for this T1 A1 lock A1 lock A4 and T2 lock A1 lock A4. So there will be an edge from T1 to T2 by A1 or A4. Similarly, in T3 lock A3 lock A7 and in T2 lock A3 lock A7 is there. So there will be an arc from T3 to T2, that is A3 A7, and this precedence graph shows that there is no cycle, so there will be no any conflict. So this schedule is serializable and the order of the serializable will be either T1 T3 T2 or T3 T1 T2. And the advantages of this tree-based protocol are we can unlock the data item anytime, so that the waiting time for a data item will be less and the increase of concurrency. And because we know the order of the sequence, so there is no any deadlock in tree-based protocol. But there is some also disadvantage, that is, at first we know the parallel knowledge of data access, and we already see that the unnecessary locks is there for granting the tree-based protocol. So in next class we discuss the another non-two-phase locking protocol, that will be the timestamp based protocol. So that will be now from, and thank you.